Welcome to the DNA of Things. I'm your host, Dr. Jeremy Koenig. This is a podcast that delves into the future human potential, the lens of health, science, performance, and longevity. Each week, we journey with top minds in the field, exploring revolutionary practices and next generation thinking, all aimed at enhancing your health span and extending your human capability. Let's dive in. What if the real breakthrough in medicine isn't another drug, but learning how to listen to the softer sounds in all of us? So for too long, we've treated chronic disease as an enemy to be suppressed, our own bodies as battlefields. But our guest today, Omer Ozkan, reveals a hidden conversation happening inside of us, a microbial language that holds the key to resilience, health, and longevity. An engineer turned healthcare innovator, Omer harnesses AI to decode the gut microbiome's complexity, turning raw data into precise nutritional strategies. His work challenges the status quo of symptom management and invites us to see health as a system problem to be solved, not a fate to be accepted. Today on the DNA of Things, prepare to explore how reimagining our relationship with our microbes might transform medicine itself, from fighting disease to cultivating balance. Omer Ozkan, the founder and CEO of ENBIOSIS biotechnology, an AI-driven microbiome company revolutionizing precision nutrition and personalized medicine. Originally trained as an industrial engineer at Bilkent University, Omer built a successful career in renewable energy, founding Turkey's first solar energy company in 2013 before transitioning into biotechnology more recently in 2018, and with a vision of decoding the microbiome's complex language, ENBIOSIS, and Omer at the helm is pioneering the AI-powered approach to personalized diets that have shown some really exciting clinical success in the realm of, IBS and other chronic disease conditions. The company's evidence-based approach using AI technology is operational already in more than 15 countries, including North America, Europe, MENA, and Africa. So Omer sees the gut microbiome as the key to unlocking longevity, resilience, and disease prevention. And his mission is to transform microbiome science through theoretical discovery to real-world therapeutic applications, shaping the future of data-driven healthcare, wellness optimization. Welcome to the DNA of Things, Omer.
Thank you. It's my pleasure. Thank you, Jeremy.
How was I connected to you? I was connected to you through Vexia, through Ryan, actually.
Yeah. Yes.
That's right. And, I got to say, I think we were fast friends right away. At least that was my impression, with this kind of shared passion for the microbiome, the gut microbiome. I'm not sure if we talked about it at length or not last time, but I spent a lot of time, in my postdoc focused on working on the first case study as to how the infant gut is colonized. A lot of that pioneering work as a result of Dr. Jeffrey Gordon, a gastroenterologist, his postdoc Ruth Lay, and Rod Knight, also an incredible innovator on the software development side of things. And, that was 15 years ago now. And so to be reconnected with you and seeing that you've, picked up this mission and that you bring, this amazing background and perspective as a industrial engineer working in environmental sciences, I'm really excited to understand how you see it, how you see the opportunity. And, maybe before we dive into, the company specifically, before we dive into ENBIOSIS, I'd love to learn more about, your upbringing and, how you became an engineer and then what triggered the switch into your passion for the microbiome.
Yeah, thank you. Actually, since my childhood, I do like shaping the future in my mind and jumping into that dream and trying to realize what I see. And even industrial engineering those days, when I did choose industrial engineering, was about to create my roadmap. And when I was a student at university, I was actually thinking about the future again. And for a long time, I was being affected by the future risk of climate change, and the world was going to change. Even, in mid of 1990s, when I was in primary school, I was feeling that. I was feeling about the future of risk. And during the university, I just wanted to jump into, the renewable energy, because I was seeing the renewable energy is one of the valuable things that we can do to contribute to Earth, to save it. And that was about the future. And I jumped in. Yeah, when I jumped into this business, the renewable energy business, it was quite new, especially when I was in Turkey those days. There was no regulation, no law, and I just jumped in and tried to do something. After all those years, I'm proud of leading, one of the leaders actually, developing the sector and building the first plants. Nowadays, people are doing a lot of solar power plants, wind power plants, and different types of power plants after all these years. And I feel good. And it is same for the AI and the biotech. But actually, in around 2017, after I felt the power of AI, I see okay that the future is coming, and in the future, there are people who create value in the future, and there are people who benefit from the future. I do love to do the things, opening the door for others, and that's why I just spend all my earnings to discover new things, especially AI. And the biotech is one of the startups I was discovering, and fun. I had my own venture builder and trying to discover some genius people, scientists, and speak to them, spending my time on understanding about the science and how we can connect the science with AI. And as a result of all this, sessions and days, weeks, months, really days and nights, I met my partner today, still my partner, our CTO, and learning about the microbiome gave me something, it was interesting moment, because again, I just see something. I remember, that there are some moments in my life, I felt so strong, and I said, yeah, that's it. Because when I first met the concept of microbiome, I said, yeah, if this is the door for life. If we can understand the language of these microorganisms, we might understand what the life means. That's how I started this journey. And, since then we have done a lot of things, and we are still discovering, and it's a discovery for me. And what I love about the microbiome is it's a deep, science and philosophy and the discovery area, and I'm enjoying it. And it's always opening a door for me to be a part of future.
Mm. When you describe how you essentially left one industry to another, what is striking to me is, well, you were probably, let's say, classically trained or institutionally trained in the world of becoming an industrial engineer. Is that fair to say? University or professional school, etc. Yeah. Well, and then, you talked about, well, now I was going to go into biotech, and the way that I got there was talking to experts. And what I find about, getting to do this show, for example, is I talk to so many people who are experts, and just through dialogue, I learn, so much more than I would have ever learned previously, like in textbooks or doing my own research. And, even adding that kind of layer of collaboration that's possible. And then that's, exponentially increased through, like video conferencing, like what we're doing now. And then all these tools of analysis to consider all these complex ideas, all these complex systems, and to think about how they might be harmonized. And, thinking about that from like an engineer's mind, where, they're very, very astute at, problem solving and systems thinking. Yeah. I think it lends itself beautifully to, what you see in what you're probably seeing in the microbiome. I'm going out on a limb here to guess. I think you probably saw that quite naturally. again, with your formal training, but still your ability to, pursue dialogue, to continue learning through collaboration. And so, I would like to know your perception of the microbiome, because it sounds to me like you were very much in awe of it, but you're also making it practical. But, this notion of an interactome, right? A very interactive system, the microbes with themselves, but then also with ourselves, and, leading us to a bigger question: who are we, or what are we really, if we have more microbes on us and in us than we do human cells? 100 or 1,000 times more genes. I can't remember the number, but it's a lot. And, so I'm really interested to, I guess, understand maybe at a meta systems thinking level, how you see that, what enticed you about it. And then, what was then from there, developing that paradigm, what was, kind of the first, let's say, problem that you set out to solve it in health?
Yeah, actually, first of all, the bacteria is the initial point of our evolution, and this is quite interesting because if we really want to understand what the life means, especially what the living thing means, we need to understand where we are coming from. The initial point, how did it start? Actually, the starting point is very interesting, and so far, after all these billions of years, today who we are is the result of this evolution. And when we look at all the process all the way, we are living with the same organisms. They never left us. Yeah, we have changed so far, but these organisms are living with us. And as you said, their numbers are more than our cells. Okay, more or less our cells, and they are speaking to each other. They are sending signals to ourselves, everything, and they are at the core of all the communication in our health. And what as an not only engineer but as a person, in my previous business also, I was quite out of the window. And what I'm trying to bring a new perspective to the microbiome as well, because the health is, we are always looking for, to solving the problem. Since the beginning of human history, when there's a problem, we just focus on that problem to solve it. But, what I see is, all the problems, this is a theory actually, but very strong theory after all this, the studies, and in the future we will, I guess, make it more clear. What I see is, that there's about all the communication problem. Because if there is a really, the healthy communication in our body, everything will work, in a right order. And the microbiome is the center of communication, is the everything, every signal, what's happening in our health, through the signals of, the bacteria. And what I have seen is, yes, if we can understand their life, their missions, and their communication. And if we understand how to change their population, if we understand how to manipulate, their life in a good way, so we will have a chance to fix the cause of the problems, which is, for me, the communication. And we have seen really proof of what I am saying in our studies. For example, for the irritable bowel syndrome patients, when we look at their microbiome, some of the groups of bacteria are dominating the population, and their real numbers, ratios are more than the others, which is quite, I'm always comparing the life of the bacteria is a little bit, how we are living in our life. It is in a society, if a group of people like become an oligarch or, monarch, or they have the power, at the end of the day, the population collapse and there will be a lot of problems. It is same for the microbiome. And when we see, for example, irritable bowel syndrome patients in our studies, some of the group of the bacteria are dominating the population. And what we do is when we try to reduce their numbers by starving them. Because very interesting, not all of the bacteria are feeding the same food. Then what we did use, okay, we just store the targeted, the bacteria, while increase the number of, the others. So trying to stabilize the population, diversify the, ecosystem. When we do it, we see the results. We see the results means when there's a diversification, when there's a diversified, ecosystem, in the end, we see people's problems are solved. Their symptoms are gone. And it's not only for the short term. We have also the 6 months and 12 months follow-up study. When you solve the intelligent problem just once, it keeps a long term. It's not just the 1 day show. It is a long term, because when you fix the communication, so even the system are really strong against the external factors. So that's why, as an engineer, not only engineer, as a person, bringing the idea to microbiome with our part. My partner is the actual center of the technology. I am the behind of the philosophy, but the philosophy since the beginning is to understand this, their language and stabilize and, to fix the problem, fix the communication. And that's actually how I see microbiome. And that's why it is the center of health. Once, let's assume we are living in a simulation, 99% of the, the codes or in our body is full of these microorganisms, 99, which means if we are going to fix, the problem in the software, we have to focus on the measured population. That's what we are doing.
Yeah, I want to pull on the thread a little more there, because, on this idea that, all life started as, bacterial, let's just say, for the sake of argument. Well, in case there's any evolutionary biologists listening, there's obviously the distinction between archaea versus bacteria, but I don't think we need to dive into that. But the point is, there's this, those are thought to be the beginnings of life on Earth. And of course, there's even a question outside of that, how did it get here? Was it formed spontaneously on Earth, or did it arrive, through this process called, panspermia? Was it delivered on asteroids, for example?
Yeah, probably, yeah.
Right. And that's what, spawned a lot of the work that Carl Sagan did, I think, back in the, would you say 80s? Yeah, 70s and 80s. And so that's a very profound question. How did that start? And even as you think about, the coevolution of bacterial cells and, the eukaryotic cells that make us up, the human cells, mammalian cells, is this notion that, an ancient humanoid-like cell called a eukaryotic cell, instead of, engulfing and digesting an ancient bacterial cell, it found a symbiosis in it. Instead of digesting, it farmed the bacteria, and then, that progressed till, what we see today. And that's what we call our mitochondria, the energy powerhouse of the cell. And similarly in plants, that's true for their mitochondria, but also the plastids that do the photosynthesis. And so it's really interesting. It's important to understand, I think, that, again, pressing on that point, the intricate play of this evolutionary process. And I do apologize. I didn't mean to confine you to being an engineer. It's just I've spoken with a lot of people with engineering backgrounds lately, and it's rekindled my interest in more systems thinking. So of course you're a human. So I I apologize. I would never want to limit you to certainly one discipline. The other thread I wanted to pull on, just with the microbiome stuff that we're seeing, because it's real stuff, right? It's like there are these microbiome host genes that, they interact with, different genes to affect lactase persistence. So I think FTO gene, there's immunity, various immune system genes like FUT2 and MHC, brain function, so serotonin, tryptophan production. It's been linked to autism risk, various disease susceptibility like Parkinson's and different forms of cancers. And again, this all kind of coming back to this notion of crosstalk through, digestion, immune tolerance, neurological health, even altitude resistance in some instances, Tibetan populations with koala detoxification. So you wouldn't think that is necessarily happening because of these amazing little microbes, right? But yet here we are. And, this isn't necessarily a part of clinical care at this point. But one other thing that I'll say also is, the C-section babies, right? So those babies that don't go through the birth canal and get exposed to the vaginal microbiome, have an increased risk of things like, chronic disease, like, asthma and allergies and inflammation, et cetera, autoimmune disease, essentially. So yeah, there's something that you're doing here that it lends itself to this kind of rethinking, like a Maslow's hierarchy of, how we define the animal, the human, and then how we approach the health by breaking it down. And so you've got some, preliminary, examples of this. And what's really exciting is we're starting to see the microbiome being used for clinical applications. So I'm interested to know, like, what is that conversation like? Because, clinicians they're not necessarily expert in microbiome. So what are you seeing in terms of, I guess, the knowledge translation and implementation to professional practice? What are you learning from that world?
So what I am learning is about IC is resistance, actually. Because people are scared about the things that they don't know.
Right.
And the problem of the microbiome is, unfortunately, most of the doctors, they haven't studied during their medical school because it was not there before, and now they have started to read about it, but it's noisy. They hear a lot of things about the microbiome. That there's not some one standard rules or one standard information that they get all these things. Unfortunately, everybody says something about it. Yeah, there's a common word which says, okay, the microbiome is crucial and important, and it's critical. But apart from that, people say a lot of things, a lot of different things, and that's why I understand the medical professionals. They are not very close to the use on their practices until it becomes standard or regulatory approved, and that's the problem of today. And when look at the regulatory authorities, especially because the microbiome is only an ecosystem here that we carry, but are using different types of applications to change this microbiome. And nutrition is the major factor, the main factor that change it. Especially when you speak about nutrition, oh my God, everybody speaks about the nutrition, and although you are, that's the problem. That's the problem, and we are trying to position ourselves. Look, we have evidences not only about the clinical evidences, but also we are proving it the mathematics with the microbiome data. We can show how we change it when we change what happens, all the correlations. We are trying to bring a new idea, new rules to the system. It's not easy to make people to accept this idea because it is so strong. What we are saying is, we can modulate the microbiome. That's the first thing we are claiming. And the second thing is, when you modulate the microbiome, you are able to solve the cause of many diseases, a lot of diseases. When you speak about the, very strong claims, and when you claim it, we are doing it with the modulation, and the modulation is just done with the natural food and supplements, it becomes quite, problematic and with the question mark for people. Although we are, putting a lot of evidences, it's not enough. It's going to be enough, but, we are trying to lead this. Unfortunately, there are different companies in the market, and they are not creating evidences instead of, the marketing activities. We are the one trying to, add, the more evidences, more data to support that the modulation is possible, targeted modulation is possible. And when you do it, you change it. you solve it. But we need more time, I guess, because we feel we are quite alone, to be honest. Yeah. But,
Yeah.
the change is not easy. We are trying to lead this change.
I try to get into the hearts and minds of the clinicians who, well, they're just saying, oh, here we go, not another test, and like a very complex one at that. And how does this become a part of my differential diagnosis? And I guess the first thing that I think about is, well, at what point of the care plan is the microbiome introduced? Because if you're into some kind of acute trauma, or maybe you're down the road with chronic disease too far anyway, it's hard to implement something like the microbiome, which some may argue is like an auxiliary data point. I don't necessarily agree that that's true. So, and then the conflicting results, okay, how to use it and what is a healthy microbiome? And I mean, that's even an interesting question because, as I mentioned, when we did that case study of the infant, that was just one infant. I would call that study, that wasn't like a hypothesis driven study. That was a hypothesis outcome study. So it's like, let's just track the infant development, journal everything from a phenotypic lifestyle development point of view, and also collect fecal samples along the way and assess the diversity every day for basically the first, I don't know, what was it, 2 or 3 years. And so then when you start to get an accounting of the changes in the system, you can infer, you can correlate them with different, let's say, events in the child's life. Of course, you can't say that it's causative because there aren't enough data points. It's only one child, but actually, even when you look within the one child, you can see there's a recurrence of multiple issues. So, okay, here's an example. When the child is born, basically the diversity is very low. The microbial diversity, there aren't that many bacteria. There aren't that many different kinds of bacteria. And then what do we know in that particular scenario? Well, the infant is vulnerable, right, to infection by external pathogens, because the nice thing about a diverse community in the gut is it protects from invasive bacteria that would cause harm and want to build a home. And so what do those good bacteria do to earn their keep? Well, they break down fiber. That's why fiber is so important. And that's like the primary source of fuel for the epithelial cells in the gut. So literally the bacteria are feeding the gut cells. And so that relationship's been established and is, looking to reestablish itself new in that infant. But as you go through, you start to see the diversity increase. Interestingly, at first, the infant gut microbiome actually looks more like the mother's vaginal microbiome. It doesn't look like an intestinal microbiome, which makes sense because that was the exposure, right? And then you actually see a lot of the microbiome that you would expect to see on the skin. Why? Because there's a lot of skin-to-skin contact, right? Breastfeeding. So actually comparing breastfeeding is one of the greatest probiotics, is comparing the microbial content in the breast milk to the gut microbiome. You can see that actually starts to build, and it's environment specific, which is amazing because the mother's immune system has kind of developed that cocktail, if you will. But then you start to go along and then you see, there's an ear infection. Antibiotic. Boom. You were growing this diversity and then boom, it's gone. And that happened multiple times, which is not surprising because antibiotics are not so precise, right? And I'm not saying don't take antibiotics. I'm just saying take them responsibly. But it does affect your gut microbiome, certainly. We saw changes when the baby introduced formula, right? Now, we only saw that once, so I can't say this always happens when you put formula. But we saw changes when the diet changed. Different changes every time when, vegetables were introduced or meat was introduced. It's like, this is a change. And we could measure it statistically. We could even measure how the communities differed and even the genes, the functional genes, how they differed over time. So what I took from that is it's hard to look at any one point and say, okay, yes, your microbiome is on track. But if you can look at it in context, right? You can look at it over time, and maybe this becomes something that people eventually do a few times a year, just as kind of a good practice for taking inventory of your health. I mean, I think that's nice. It's a nice to have, but what about the need to have? I think about the need to have is like, well, the babies who are delivered by C-section, as we mentioned, it's like that's a very good use case of covering the baby with like a vaginal swab taken from the mom, and that's being done in some places. The other thing, that I was very concerned when I lost my appendix, right? Because I lost my appendix around, I got food poisoning and I had appendicitis, and so it was around 2003 when my appendix were taken out. Oh, it's an evolutionary vestige. You don't need it. I was like, I don't believe that. It doesn't feel right. And as it turns out, in 2008, it was discovered that it's actually it's a safe haven for good bacteria in the event that you do get food poisoning, et cetera. So it's like, maybe that's a good target, is people who have had their appendix taken out. Is like, oh, well, you especially need a reservoir of good bacteria to have at the ready when you get food poisoning, because you don't actually have that anymore. And then there's the more obvious stuff that is very, clinical, and that's people who are suffering with C. diff, chronic Clostridium difficile. Basically, they have one kind of bacteria living that's taken. It's like the Agent Smith of the microbiome. It's completely taken over the matrix, right? And so rather than, here have more antibiotic, which is just going to increase the diversity even more, or nutrition that is not going to be supported by the community, there's, this whole notion of, gut transplants from a healthy donor. So I think it's like, okay, how does this become implemented into the clinical care? I think it's like, okay, well, we solve the problems that we know it can solve. So like C. diff, appendix, post-appendicitis, cesarean birth, or and then all the other stuff that you're talking about is like case by case, because I think it's never ending when it comes to like chronic disease, So anyway, sorry, that was you've unearthed this silent passion.
No, that's okay. Actually, first of all, I would like to correct, if you don't misunderstand, the thing that everybody is using about the good and bad, good bacteria and bad bacteria.
You're right. Yes, thank you.
Yeah, actually, it is. There's no good bacteria and bad bacteria.
You're right.
Everything should be in a balance. As our life, there are good people, bad people, whatever you name it. But we have to live all together because we have all talents, different characteristics, different missions, and something is bad if their ratio is more or less than the healthy ratios.
Right.
So there's healthy ratios and unhealthy ratios instead of good and bad bacteria. First of all, I would like to say it. The second thing about the antibiotics. Antibiotics probably this century will be the last century for antibiotics, because now the targeted bacteriophage and different types of we are creating different types of tools instead of just adding a nuclear bomb, because nuclear bomb is an existential threat, and we are scared of the nuclear bomb in our life, and if there will be a World War III and if there's a nuclear war, we are scared about our life. It's the same for the bacteria as well. They are also scared. They have also life, and they are living with us. We need them, and if you just bomb them with the nuclear, you are just having an existential threat to them. So it's also something very primitive, and it's going to change soon too. We are here actually to change this dynamics, the understanding, and the life. So if we give them, our partners, bacteria are our partners, a life to them. If we give them a life, they will give it back. So it's a mutual benefit. But so far we have always been targeting as a killing the bacteria. When we look at all the products, 99% kill the bacteria or whatever. It is like they are the enemies. No, they are not enemies. They are actually our best friends. They are our best partners if we can manage it. And today AI, if we speak about the AI is a tool. AI is not just a target. But unfortunately, AI is also misunderstood. since the chat GPT, people just think that the AI is just the text mining and answering the question with, the language processing is different. The molecule process is different. Today, our AI is a tool to manage, to understand and manage this living things. Actually, I'm using this metaphor to make people to better, understand easier. We develop our own the AI in the gut. So there's an intelligence in that. This intelligence is managing the living things, all the living things that is normally impossible to manage. But with the information, data, and the power of AI, that's what we can do there. And it gives us a chance to manage our best partner. Instead of being an enemy, when you can manage something, it can be your best tool, right? So microbiome is our best tool to survive. And today AI is supporting this idea for us.
Yeah, I like the metaphor. When I was deeper into the microbiome research, the way that I looked at the data, and I'm talking about the infant colonization again. If you're familiar with you're probably familiar with Jared Diamond's Guns, Germs, and Steel, right? So basically, here's how societies that conquer, let's say, are developed. I think about it now. It probably wasn't the best analogy, but whatever, I used it. And the point is he was proposing a certain set of steps that were necessary for societies to, let's say, become peaceful and prosperous. And, part of that had to do with like the environment itself, where people found themselves, and then cooperation. So the formation of social structures that would lead to collaboration, and then, innovations and technologies. And, those would translate, obviously for, medicines, let's say, and then ultimately, to weapons. And then we get into kind of more, the darker, more forceful side of the story. But the point is he laid out this formula. And when you talk about AI is not Chat GPT. It's just kind of one instance of it. All these classifying algorithms that exist, to do evolutionary studies using our, human DNA molecules, right? To define ancestry, like those are based on phylogenetic algorithms that are based on machine learning and testing and building these models. And you start with this assumption, the artificial intelligence, and you kind of save a lot on the computational time. And so in the same way of doing all the analysis of these different populations of bacteria, because it's no small deal, right? Like you need algorithms to understand how many, what different types, and then is there co-occurrence of these types? And then you can really start to build a story of the community dynamics that are happening, let's just say in the gut.
Yeah, correlations with the health parameters, diseases,
right.
And chains,
right.
A lot of things,
right. Yeah.
Multi-billion parameters you need to run.
Yeah. But the interesting thing is it allows you to get to the point of say, oh, well, that's a keystone bacteria, for example. It's like, oh, well, it may not be there. It may not be abundant, but if it's gone, the whole system collapses. Like this comes back to what you were talking about with, it's not good and bad. It's like the harmonization of what these things can do. And I think I have to really press on that point of the AI analogy more, because most people probably don't know that the majority of bacteria in your gut, for example, you couldn't isolate them on their own and grow them in the lab, for example. And so you would never know that they were there unless we had things like metagenomic sequencing. So that is, you can take a whole fecal sample and sequence the whole genome and then infer who's there and in what abundance. And that's pointing to just how incredibly interdependent the system is. And so I'm really interested in, kind of what is the future metric? Because we don't exactly know. When I was doing this, I was playing in the sandbox and I was thinking, oh, it's the species of bacteria and the abundance. But again, if you start to think of it as like, maybe it's an interactome, it's a network, and there are nodes and edges, and maybe there is a way to quantify it mathematically in terms of like, again, an ecosystem and an interactome. And so, how do you see that going? How do you see it How do you see us applying mathematics to this, if that is indeed what we should do?
Yeah. We are already doing that because there's the mathematics behind. First of all, you can understand with the AI and data. That's what we do.
Yes.
About the correlation between the potential diseases, our wellness parameters. We can easily understand your sleep quality, your mental health, or your metabolic activity. So everything is correlated with the ratios of the different bacteria and their all population. So what we do is we change the population. How we change the population? We are choosing a healthy population donor. It is like in fecal transplant. If you know the fecal transplant, what you need to do is you need to find a healthy donor, right? And you just need to transfer the stool from the healthy to the patient. So when you transfer it, what you expect is the bacteria from the donor to the patient, there will be an interaction, and after the interaction, the patient will be recovered, because the assumption here is, and the results are also supporting it, when you mix these two profile, the other look like to the healthy one. So then we are doing the same thing, the fecal transplant, but instead of clinical fecal transplant, that's impossible to scale and there are lots of risks. We do it in a digital environment, and we are choosing a healthy donor for each individual, and we are shifting each individual to the targeted healthy donor in an opposite way. And the system is easy, and because each of the bacteria, are, you can fit with the different types of nutrition, and when you use different types of molecules, the nutritional molecule, you are able to shift it. You are able to change the population. And if you have a targeted healthy population in your hand, in your biobank, you have a strong chance how to do it. Because today with the AI and the simulation, you can easily predict how can you manage it, how can you shift it. That's actually our discovery. Our discovery is we have discovered a way to do fecal transplant without clinical fecal transplant. Instead, the same mentality with the digital environment, using the food and supplement to the opposite way. So that's how we are shifting people's profile to the healthy one. This is quite unique, and today we are doing it with the diet and these supplements, but we very soon in the future, because we are also enriching the data bank. But very soon in the future, we will have many clusters, which means today we need to test, we need to see what your profile is, and we need to find the healthy donor for you. Okay, that's how the system works. But when we have enough data for some main clusters, let's say for people who have IBD, for people who have some eye diseases or some skin disorders, so you don't need to test everyone, because there will be a common population problem. So you will have a chance to provide the generic formula. Okay, that's just one formula for each cluster that will fix their problem. So very soon we will have a lot of different formulas for different diseases that will help people to modulate their the microbiome, even without testing. The testing part will be kept for the individuals, for the longevity, to make it better and better. But what I'm saying about is the some main typical the disease-based clusters, you will be also able to change it with the optimum formula. So that is what we have. And I guess this is something we are proving what the Hippocrates said more than 2,000 years back. Everything is in the gut, yes, and food is the medicine. So if you use food in your gut to feed the right bacteria, to make them to produce the right metabolite, it is going to be your right medicine. Today, the microbiome is like a factory, and this factory is producing medicine for us. But the point here is what kind of medicine you need to produce. And we know how to actually make these guys to produce the right drugs for us. And that's actually the mathematics behind.
Got it. So you're saying that, there are these different classes or clusters of chronic disease, and based on how you self-report, you can guess how the microbiome was off. And with a relatively uninvasive solution, nutrition and supplement with little to no side effect, we know we're moving towards a healthier gut microbiome, and you can see results in a week, 2 weeks, 6 weeks, whatever. Is that kind of the protocol? How?
Yeah, yes, exactly. By the way, but I don't agree with the no side effect because it's a basic mathematics actually. If something is a serious positive effect, the opposite application of the same thing might have very negative effect too, which means you can solve any kind of problem with the food and supplement, but you can also kill people with the wrong food and supplements. So it's not very naive and it's not innocent food and supplement area.
Right.
I guess this is the misunderstanding of any regulatory authorities. It's very critical, especially today. Food and supplement should be considered as a drug for people, and especially in the modern life, we all have, unfortunately, different types of microbiome. It was not the case in the past. We had similar profiles, especially people who had similar DNA, living in the same environment, exposed to the similar environmental the factors, right? We had similar problems. But today we all have different lifestyles and we are exposed to different environmental factors, and so the risk here is very risky. Every day when you wake up from breakfast to dinner, everything what you eat is risky today if you don't know what to eat. Unfortunately, this is reality. That's why people are sick. That's why billions of people have chronic diseases and nonsense. What does chronic mean? Why people have a chronic problem? Chronic means because you cannot solve the problem. That's why you use the name of chronic. Everything should have the solution, and the solution is hidden in the gut, and it's there. We know it. We are doing, and it's just a matter of time to make people to understand and believe it.
So it's interesting. You started this entrepreneurial pursuit. I think you told me around the time your daughter was born. Is that right? Yeah.
Yeah, exactly.
And what you said at the beginning of this call is, you're all about planting the seeds for the future.
Yeah.
What do you imagine that future to look like? What future are we pursuing? Are you pursuing with this microbiome AI powered intervention? What future are our daughters living in?
Actually, our part is actually to make people to survive under a difficult, conditions of the future, which means, we don't know what's going to happen, but we all feel something, the difficult days might come in terms of climate change, and it might affect our life, etc. And yes, it is also possible that we might leave Earth or find other planets to live, etc. But whatever we do, we need to survive, and to survive we need energy, and the energy, how we produce it with the nutrition with that we take, and the nutritional problem. That's actually if we can solve the nutritional problem, which means we are able to solve any kind of chronic disorders. We are able to solve cancer. We are able to solve any kind of other disease as well. Okay, it's going to extend the human life. First of all, we can really expect our generation. By the way, I'm expected from my lifetime. Of course, anything might happen, like an accident or whatever. But apart from the unexpected things, for the biological, diseases, we might really reduce this disease. We are able to extend our life, and I do expect minimum 2x, which means 120 to 140 for average is possible, and even our generation might see it. That's the first thing, and for the younger generation as well. But apart from that, yes, people will need the nutrition, and if you have the right formulas with the right combinations of these formulas for health, and it, You remember, like in the Matrix, right? People eat something in the cup. Yes, you can make it delicious, of course, but when there's a food problem, with the ingredients that you produce, you can survive, even, under the very difficult climate conditions. Plus, if you go to the space as well, this is also, apart from extending life, it is also essence to, to survive in the food crisis, wherever you are. These are the two things that, we can contribute to life. That's what I see. Yeah. And the third part is, yeah, we might not change what's going to happen outside, which means, yeah, there will be maybe less water. The climate conditions will vary so fast, and we might need to live maybe underground, different types of, the environmental conditions. Yes, we cannot change the external, the outside, but we can change our inside. We can make ourselves adapt, because adaptation is that's, bring us to, the center, right, in this life. And I guess we need to adapt so faster than any time in our history, human history. And in order to adapt, we need technology. And the technology behind the AI and the microbiome is allowing us as a chance to adapt when the things get darker. And I guess microbiome and AI is the light of the future. That's what I see.
Amazing. Well, it is. I mean, folks have said, if you think about, the implementation of agriculture, right? Obviously, the industrialization of our societies. I mean, massive external environmental changes, and having the internal gut changed also in parallel. So maybe there's something to, stabilize against that perturbation more quickly, right? And so that's a fascinating idea. Again, this whole like you carry your environment with you, internally. I don't think that's being talked about a lot. I mean, great, and as I say, great opportunity for the astronauts of today, right?
Yeah. We see it, when the astronauts are in space, after some time, their microbiome is collapsed, and it's even you build up a place to live in Mars, but if you don't have a technology to adapt your microbiome, you are dead.
You're true.
So
amazing. So when we started talking, Omer, I said I had 3 questions that I was going to ask you at the end, and so those were, if there's one thing that we need to communicate to the audience, what is that thing? And number 2 is, who needs to hear it? And then number 3 is, what guest would you nominate to be on the show next?
Yeah, about the first one, what I would like to say is, revolution requires resistance. That's what I should say. And if we want to change the things, we need to be patient. And nothing beautiful on this earth is, I guess, easy. That's actually what I would say. This is the first. And the second part is, I guess, the ENBIOSIS needs a visionary, big, the investors to be involved. And I guess when I look at the biography of Peter Thiel, he is the, he might be the right person if he knows the details of what we have done. And I would like, if I would have a chance, I would like to say, this might be the next big thing. And I do have lots of reasons to support the idea behind why I see this next big thing. And for the third one, whom I should nominate is actually my partner, Ufuk. He's a brilliant and genius guy, and he's the one. After I met him, I discovered the hidden part of this science, and I learned everything. And I owe him. And he has the vision about the science. And I really, suggest him to be a part here.
Amazing. Okay, well, we got to get this message to Peter Thiel. So we'll make sure that it's heard. Is nothing great is easy, that's for sure. And really excited to meet your co-founder. In the meantime, Omer, how do people find you? How do people find the company when they want to learn more?
Yeah, ENBIOSIS.com, provides enough information. our, the technology, the demo product, and our publications, etc. And on my LinkedIn profile, especially Omer Ozkan, they can see, enough information about myself. And to access either, our website, the contact form, or directly they can email me, oskan@embiosis.com.
Amazing. I will make sure that I put all of those points of contact in the show notes. And let me just finish by saying, Omer, it was a great pleasure to have a fellow passionate microbiomics person on the DNA of things. I thank you so much for everything that you're doing and being so generous with your time and sharing your story with our listeners. And we're all cheering for you and the innovation and for the future of humanity to take our environments with us. So thank you so much.
Thank you for inviting and listening. Thank you, Omer. Have a nice day.
We've just journeyed into the unseen world within us, where trillions of microbes hold instructions for our well-being. Omer Ozkan has shown us that the gut isn't just a digestive system. It's an ecosystem, a language, a code waiting to be understood. This isn't science fiction. It's a new paradigm already taking shape in AI-driven clinics and personalized nutrition plans. But the true revolution lies in shifting our mindset from eradicating bacteria to collaborating with them, from fear of complexity to embracing it. The path forward is clear but challenging. It requires us to ask better questions, to build systems that listen before they treat. And the future of health is not about domination, but partnership. And the future begins when we choose to see what's been hidden all along.
Thanks for joining us this week on the DNA of Things. Don't forget to subscribe, like, and leave a review on your favorite platform. Visit our website, drjeremykoenig.com, where you can subscribe to the show and stay up to date with the latest wellness, longevity, and human performance. If you found value in the discussion, rate us on iTunes and share with your friends to spread the word and spread the wisdom. For more insights and to dive deeper into the topics we discuss, check out my latest updates, drjeremykoenig.com, and you can subscribe to exclusive content there by signing up for our newsletter. Thanks so much for joining us, and we look forward to seeing you again next time for more empowering discussions that will take you, your wellness, and your human capability to the next level. Thank you.